Hello there, and welcome to today's class. For today, we'll be discussing a very important aspect in physics known as dimensioning, as you can see above. So, for today's class, we're considering the concept about dimensioning. We'll be discussing about the fundamental quantities and derived quantities, and also how to write the dimension for the derived quantity. And we will be using all these concepts to solve problems on JAM and WAEC cases based on dimensioning. So let's start with definition of dimensioning. What is dimensioning by definition? Dimensioning refers to how physical quantities relate to the fundamental quantity, especially its mass, that is, especially its mass, capital M, its mass, length, capital L, and time, capital T. So I'm saying that dimensioning refers to how physical quantities relate to the fundamental quantity, especially its mass, length, and time. That's like definition for dimensioning. All right, I said dimensioning refers to how physical quantities relate to the fundamental quantities. So the idea there is that what is fundamental quantities? Let's discuss fundamental quantity. What is fundamental quantities? Fundamental quantities are those quantities that cannot be expressed in terms of other quantities. So I'm saying that fundamental quantities are those quantities that cannot be expressed in terms of other quantities. One line space paragraph. The units of the fundamental quantities are called the fundamental unit. It is important to note that the fundamental quantities are those quantities that form the basic for dimensioning. So it means that fundamental quantities, they form the basic for dimensioning. There are about 7 fundamental quantities. As you can see, I'll be giving the table below. As you can see the table below. So one line space paragraph, the fundamental quantities, comma, the fundamental units, comma, and their symbol are given below. So we're saying the fundamental quantities, fundamental units, and their symbol are given below. Number. All right, fundamental quantities. Fundamental quantities. Sorry. Quantities. All right. Let's start with the table that give us the detail about a fundamental quantities. So I said there are about 7 fundamental quantities which I'll be giving you right now. Number 1 there is called the mass, which is measured in what? Kilogram, and my symbol for that is kg. That's number 1. Number 2 there is length, which is measured in what? In meters, right? Which is what the M as a symbol. Next up, we have what we called time. But the fundamental unit is what? Seconds. While the symbol is X. Next up, I have what we called the temperature. The temperature, that's measured in Kelvin. Kelvin, that's K. Next up, I have what we called the electric current. Electric current, that's ampere. Amperes, that's A. Next up, we have amount of substance. Amount of substance, that's mole. That's mole. That's MOL as a symbol. Finally, we have what we call the luminous intensity. Measured in candela. Candela, the symbol there is CD. So these are like the 7 fundamental quantities and their units as I've given you below here. So we have what we call the mass, that's kilogram, kg, length, time, electric current, temperature, amount of substance, and luminous intensity. For jam idea, I've actually taken you beyond jam idea. For jam, we deal mostly with mass, length, and time. That's all. But I just gave you this table so that you should know that this other one there exists. This other one too exists. All right. I want to understand this concept. Let's discuss one more thing before we start dimensioning parameters. So let's discuss one more thing called the derived quantity. Derived quantity. All right. Um, all right. Let's start with the derived quantities. What are derived quantities? Derived quantities are those quantities that can be expressed in terms of other quantities. The unit, it is important to know that the unit of derived quantities are called the derived unit. Example of derived quantities includes number one, we have speed, velocity, acceleration, force, mass, volume, area, we have discharge, we have pressure, we have density, we have volume flow rate, we have mass flow rate. All right, all what we have discussed are simply the example of dimensioning. All right, let's start with the first one called speed. I mentioned speed. Let's dimension speed. We said your ability to dimension any parameter is that can you define it? Look up what's speed by mathematical sense. Speed is what? The rate of change of what? Distance. That's what? Distance over time. So we are saying that speed is what? Distance all over what the time taken. Of course, look up please. Look up please. Now, the idea is that I'm going to express this derived quantity in terms of what? Fundamental quantities. Look up, I'm having distance. Which one among mass, length, time, temperature, electric current, ampere, amount of substance, which one here talks about distance? Of course, that's what? Length. So I'll use the initial to represent them. That's L for length, L. So I'll have L as my dimension for distance. What's time? Which one here talks about time? That's T. Use the initial. That's T, capital T, all over T. Of course, by mathematical approach, this one means L times 1 over T. Shift out L, I have L times 1 over T. This means that 1 over T in indices becomes L to the power the T to the power minus 1. So this becomes the dimension for speed. I give you the second one. The second one is what? Velocity. All right, second one there is what? Velocity. What's velocity by mathematical approach? It's simply what? The rate of change of what? Displacement. That's what? Displacement all over time taken. Of course, Look up, please. What's displacement? Which one talks about displacement here? What's displacement? First is what's displacement? Displacement is simply the what? The distance travel in a specified what the direction. So you see a distance. Distance is a distance. Displacement is also what a distance. So it means that displacement is measured in what? In the dimension for displacement is what? Is length. All over time is what? T. Of course, my answer here becomes t to the power what the h power t to the power minus 1. So of course, observe that the dimension for speed and velocity are the same thing. So in this case, you see that speed and velocity are simply are what? Are dimensionally homogeneous. So one dimension of parameter are the same thing. We see that they are what? Dimensionally homogeneous. All right, let's take example 3. For number 3, I called acceleration. So what's acceleration? By mathematical sense, acceleration is simply what the rate of change of velocity. So we're saying that velocity all over time taken is simply what the acceleration. What's dimension for velocity? Of course, velocity is what the L to the power minus 1. That's L to the power minus 1 all over time is what? T. Now, we express this one, I have that L to the power minus 1 times 1 over T. Shift out this T, 1 over T. Of course, from here, I'll have L, next up, t to the power minus 1 times what? 1 over T becomes t to the power minus 1, right? So, from the idea of indices, if I have like bases multiplying, add their power. So I'm saying like bases, T and T multiplying, add the power. So I have L to the power what there? Minus 1 plus minus 1. Plus minus is minus. Minus 1 is what there? Minus 2. So this is like dimension for acceleration, please. All right. The next one I mentioned force. Before I mentioned force. Let's get dimension for force. What's force? What's force? By mathematical sense, force is simply what the mass times what the acceleration. So force is simply mass times acceleration. Of course, what's mass? What's the dimension for mass? Is what the m, capital M, multiplied by acceleration is what the we just got acceleration to be what? L to the power minus 2. That's L to the power minus 2. Of course, the dimension for force becomes L to the power minus 2. Dimension for force. All right, let's get other parameters. We are done for force. Number 5. Let's discuss the next one. After force, I mentioned area. Let's discuss area. All right, what's like your mathematical representation for area? That's what length times breadth, right? So either length or either breadth to look up. We said either is what? Length times breadth. Look up. Length is a distance. True or false? True. Breadth is a distance. True or false? True. But what? A shorter distance. So it means that my dimension for area is simply what the length. I can change this one to what the is still a length too times length. So these are what already dimensioned. So what's my dimension for area? Area becomes what the L squared. L times L becomes L squared as dimension for my area. Let's get to another one, sis. Number 6. Let's get to volume. What's the dimension for volume? What's volume? Volume is the product of what? Length and breadth and height of a material. So if I have length times breadth times height, these are simply what? The formula for volume, right? All right, from here, we are saying that volume is simply length times breadth times height. Of course, height is a what? Vertical distance. Breadth is a what? Short distance. Length is a distance. Distance, that's what I can replace them as what? As L and N, right? L and N, that's the concept. So my dimension for volume becomes what? The L cube, as from the idea of indices. One is here, one is here, one is here. Like basis multiplying, add their parts, that's 3 here, as my dimension answer for volume. Let's move to another one called, this is 5, 6, let's move to 7. Let's discuss density. What's the dimension of density? Of course, density is a what? Is simply the mass acting per unit volume of a fluid, or perhaps a substance or a material. So I think the density is what? Mass over volume. Of course, what's mass? That's what? M. What's volume? That's what's the dimension for volume? Volume becomes what? The L cube. I have L cube. L cube. Let's get dimension for volume. Density. So density now is now equal to what? M. I said this denominator, shift it out, times what? 1 over L cube. This one here in indices becomes ms to the power of the minus 3 as dimension. Alright, I'm having ml to the power minus 3 as the dimension for what? There for density. Let's discuss one more concept. Let's discuss pressure. Alright, let's discuss pressure, please. 8. Let's discuss pressure. What's pressure? Pressure is simply the force acting per unit area. I told you something that for you to dimension any parameter, you must know how to define it, and you should know the mathematical sense or perhaps representation of that parameter given. So I'm giving pressure. That's what the force all over area, right? What's force? We just derive the dimension for force somewhere here. So if I can recall, that's what ml to the power the minus 2 as the dimension for force. So all over area is what there is L squared, as we did here. L squared, dimension for area. Of course, from here, shift out this denominator. I'll have that pressure is equal to what? The ml to the power the minus 2 times 1 over L squared, right? As we did in initial derivation here. Shift out the denominator, I'll have this. From here, if I take this one to indices, I'll have ml to the power minus 2 times what? The L to the power minus 2. Take this one here to indices, I'll have minus 2 as my power. So start with M, next up L. I can see L here, I can see L here. They are multiplying, they are like basis. Add their power. There's a 1 here. 1 plus minus 2. Plus minus is minus, so 1 minus 2 is what? Alright, I have minus 1. 1 plus minus 2 is minus 1. Next up, to the power the minus 2. This is the dimension for pressure. Let's get for discharge. Alright, let's do for discharge. I think that one looks strange. Discharge. What's discharge? Yes, what's discharge? It's simply what the what's discharge? Discharge is what the discharge. Discharge, that's volume over time. Volume over time. So this charge is also called volume flow rate, right? It is simply what the volume over time taken. Of course, what's volume? Volume is what the L cube over time. What's time? T. What's the dimension for discharge? That's what L cube times 1 over T. Shift out T I have this. So my final dimension for this charge becomes what? The L cube times what? Take this one to indices. 2 to the power minus 1, right? Minus 1. Multiply these two, I'll have L cube 2 to the power what? The minus 1 as my dimension for this charge. So let's take some past questions and let's solve jam past question based on dimensioning, and let's see how it works. All right, let's use all these concepts and idea of dimensioning to solve some jam past questions. Number one says the dimension for the dimension for work done is dash. The dimension for work done is dash. The dimension for work done is dash. A is given as ml squared 2 to the power minus 2. Option B, ml cubed 2 to the power minus 1. Option C, ml 2 to the power minus 1. Option D, I'm given L cubed to the power L cubed to the power minus 1. All right. The question says what is the dimension, or perhaps the dimension for par is dash. So sorry, work done. Work done. So let's get this done, please. So what's work done? Right? What's work done? Work done is simply what? The force times distance, right? Force times distance. So what's the dimension for force? We just read for force as what? ml 2 to the power minus 2 for force times distance is what? A length. That's what? L. L times L is L squared. So that becomes L times L is what? The L squared 2 to the power minus 2. This is my dimension for work done. So let's check. What's work done? A is my answer. That's for question 1 under jam. Let's take another question there. Question 2 says, what is the dimension for par? Yes, par. What's the dimension for par? I mean par. This one here. A is given as option A. Option A, that's ml minus 1 to the power minus 2. Option B says L to the power minus 1. Option C says ml minus 1 to the power minus 2. And option D says ml squared to the power minus 3. All right, let's get the dimension for par. So I said the question says the dimension for par is dash. So let's get par. What's par? Par is simply what? The work done all over time taken, right? So what's work done? Of course, work done is just this one. That's ml squared to the power minus 2. All over time is t. Take this one back. I have ml squared to the power minus 2 times, shoot it out, 1 over t. From here, I'll have that ml squared to the power minus 2 times what? T to the power minus 1, right? This one to indices minus 1. Of course, like base and multiplying, add the power. That becomes ml squared minus 2 plus minus 1 is what? The t to the power minus 3. This is the dimension for par. So of course, D is my answer. Of course, I have D as my answer to par. So another question says, the dimension for stress is dash. Stress, not the headache you used to have at home, not that one. What's stress in physics concept? Option A says ml to the power minus 2. Option B says ml minus 1. All right, these are simply the options for question 3. So what's stress? Mathematically, stress is equal to force over area Of course, first is what? ML to the power minus 2 all over area is what? L squared. We have discussed all this one, right? From here, L can simply cancel L. I have one L left here. If one L cancel 2L, left with one L. From here, I'll have that this one is off, t to the power minus 2 over what there, over this L. Shift out this L, I'll have m t to the power minus 2, right? This one times 1 over L. This times 1 is this over this L. From here, write this one here in indices. I'll have m t to the power minus 2. Next up, x power minus 1. So take m, look up. The system is MLT system, right? M come before L before T. So I bring this one back, that becomes M. Next up, L to the power minus 1, then stop T to the power minus 2. So it's a system. It's called MLT system. So we still have other system, but this one deals with what? MLT system. So MLT system. So M should come first before L before T. So this is my answer for dimension for stress. So what's the option there? That's option B, right? Option B is my answer. So this is how to solve problem. This is the concept of dimensioning. I'll leave a question. I'll read out the question now and you do that as assignment. So the question says, find the dimension, or perhaps what is the dimension for mass flow rate? Question 1. Question 2 says, what's the dimension for Young's modulus? Try to solve these questions and put your answer in the comments below. I will give you a response as fast as I can. All right, thank you and welcome to Excellent Link Academy.